Hello.
Morning. All right, so now we are going to work towards solving trigonometric equations, and there's quite a few complications to this. It's a difficult topic. Today's topic is just working with solving them graphically, but there's some things you have to understand, and we're going to build towards solving them without using a calculator in the next couple of sections. So it's really important you pay close attention to this. A lot of details that get built on in the next two sections. Our test will cover the Chapter 7 material that we did, plus sections 8.1, 8.2, and 8.3. All right, so you will have a test after we have gone through section 8.3. All right, I can't read those. Okay, so here we go. So there's two kinds of trigonometric identities. We have identities, or equations. We have the identities, which we learned how to work. You did some of that. And then we have conditional equations. These are equations that are true for certain values of the variable. All right, so solutions can be found by algebraic techniques. We will get to that in another lesson coming up. Chapter 7, our variable t was used for trig functions so that we would not get confused with x's and y's that show up in definitions and that you're used to with other functions. But now you can expect the variable x. You can sometimes expect y. Unless it's otherwise stated, all trig functions are considered functions of real numbers rather than functions of angles. In fact, in the examples we're going to work, we're going to solve everything in radians, okay, except for one problem that we will do in degrees. So it is time for you to be sure you go back to your calculator and understand how to switch from degrees to radians. And since this section is on graphing, you need to be sure you understand that you also, if you're going to graph in degrees, you have to change the graphing settings as well as the general settings. All right? But for what we're going to do, all but the last example will be done in radian measure, which is real numbers. Okay, so there's two methods that we're going to use, the intersection method and then another method, the x-intercept,
which we've done before.
We've done that using solving quadratic equations and polynomial functions, so that's not new. What's new is the problem that trigonometric functions create with periodic solutions. Okay, so we're going to graph the tangent of x equals -1, and notice that what we have done is we have let f1 of x be our tangent of x and f2 of x be -1. Now, if you look at this, let's remember tangent is periodic. That means that its pattern is going to repeat, so we actually have several solutions. And now what we have to do is figure out which one of these are we going to use. What's the other thing that's really important about tangent?
It has a period of pi.
So you can see, because we haven't done anything complicated here, you can see that more than likely these solutions, these intersection points, are happening pi units apart. Now, that is not always the case. It depends on the function. And like I said, this gets very complicated by the time we get to section 8.3. So, which solution do we pick? Well, you're going to learn when we go to section 8.2 which solution we pick, which one is the best one. But we are going to take, let's just say, the one closest to the y-axis. We'll use that one. And that happens to be negative 0.7854. And that's x equals.
And we know since its period is pi, that we're going to add plus pi times k.
And you might say, well, why don't we do pi or plus or minus? Well, because k is an integer, so that means k can be positive or negative numbers. It can be -3, -2, -1, 2, 3, so forth. Okay? Now, could we have answered, notice that the solution that we got on the calculator is this 2.356 number. Could we have done that one? Sure,
yes.
We could have. But for the purposes of today, we're just going to say let's pick the one that's closer to the y-axis. You'll understand that later. Okay?
Okay, so pick the one closest to y-axis.
Okay, now, let's look at this one. The x-intercept method means that we are going to, first of all, set this equation equal to 0. And while you don't see the equation all the way, oh, there it is. Yeah, there we go. Okay, so we have set it equal to 0. Now let's look at our solutions here. Again, we've already gone ahead and said find us a 0, and we found this one. Look, do you see another one? Okay, notice that this 0 is on the increasing side of the curve. All right, let's find another 0 that's on the increasing side of the curve. Okay, so where do we have one on the increasing side of the curve? Well, way down here we have one. All right, but there is another 0, and how far apart are those? Well, sine is a period of 2 pi, so all right, so we probably are going to figure out that that is a length of 2 pi. All right, but you can see that there is another one, another 0, and we're going to take this one over here, and when we go to solve that one, that solution is 2.8053, okay, comma 0. And we can find another, notice that this is on the decreasing side of the curve, so where is there another one that is on the decreasing side of the curve? Right there, 2 pi away. So our two solutions for this problem are x equals 0.336 plus 2 pi k. All right, so I can keep going to the right on the red dot, and I'm going to keep finding, and I can keep going to the left and find some of those solutions, infinite solutions. And our other solution is x equals 2.805 plus 2 pi k. And again, I can go to the right or to the left, and if you want to specify, remember, k is any integer. Okay. Now, note, I guess I forgot to put this in, but since the graph is periodic, the solutions are going to differ by multiples of 2 pi, since we're dealing with the sine function only. Just like the last one, we dealt with this tangent function only.
Tangent.
So again, these are things to consider. Now, before we go to the next type of equation, what we have to do is make sure you understand how to enter things. We want sine squared x. To get sine squared x, you're going to have to embed the entire function sine of x. Notice that there are parentheses around the x. The x is called the argument, so it's going to be sine x, close off the parentheses, but you need a parentheses before the sine and after the sine, and then you square. Otherwise, what's going to happen is it's going to square the x. So we want to be very careful about that. Okay? Here we go. We are going to solve this by the x-intercept method.
So what you would type in is 4 times cosine of x squared plus sine of x, notice my parentheses, minus 2.
Right, and notice,
F1 of x.
Right, and notice that what we have here is, oh, that's good that you did that. We have got, pay attention, it says x-intercept method. That means set it equal to 0. Okay? Now, notice too that we have two different trig functions here. We have cosine and we have sine. But both of those have a period of 2 pi. So from that information, we know that we're going to be able to say that these results are going to, I'm going to keep getting the same values every 2 pi k. So that's because these two functions are just period of 2 pi. All right, so we've already graphed these, and you can see that in this window, what we've done is gone from negative 3 pi to 3 pi. That's what that number is, okay, and I believe that's what's on your notes, is going from negative 3 pi to 3 pi. You can kind of get a feel on this for what is happening on the function. Notice we have some places where our minimum is lower than
deep
other
dip.
places. Yeah, deep dips and little dips. Okay?
Shallow dip. Deep
so
dip.
It appears to be happening like that consistently. We can see a couple of zeros that we have found. Notice again, we have our zeros that are happening on the shallow dip, on the decreasing side of the curve and the increasing side of the curve. We also have some on the deep dip on the decreasing and increasing side of the curve. So what we want to do is blow this up, and if we look at the second graph to the right of this, you can see that we've got several possibilities here. Okay, so it turns out when we go to find these solutions, this one is 1.003. Okay, and then
So I'm going to go ahead and write that down. X equals 1.003.
And we know it's going to happen.
Plus 2 pi k, because that's going to happen every 2 pi units. I could go over there.
Right, and that's the shallow dip. Let's look at the increasing side of the shallow dip.
So that's 2.138. 8
or 9. Yeah.
Plus 2 pi k. And then, so these are the shallow dip ones.
Mm-hmm.
Now we're going to go to the deep dip. And the deep dip has, this one's right here is 3.77. So x equals 3.777 plus 2 pi k. And the other one is 5.648 plus 2 pi k.
X equals.
Yeah.
So you can see, and if you go back and look at the expanded graph, you can see that there's quite a few solutions. Now, why did we pick the solutions we did? Why did we not pick on the left side or the right side? You know, it gets more complicated. For today, let's just deal with the solutions we have. We chose those 4. We chose not to use the negative ones because we like positive numbers better. Okay? That's not really a good reason, but it'll work for today. Okay.
All right, so go ahead and use your calculator to solve these equations.
Okay, what we have to see is we have to see your graph. You need to sketch the graph and your window. So we need to be able to see, just like you saw on those axes, what your window was. And we need to see your answers correct to 3 decimal places.
Okay, now do we want them to do, like for this one, is it intercept method or do?
You know what? Let's do this one. Let's do intersection, like example 1.
Intersection method.
Intersection. There we go. Intersection. It's a new math word. Can you tell? It's still morning and we're tired.
Intersection method.
Right.
Okay.
And number 2, let's do x-intercept method. They're set up that way, so that makes sense.
All right.
Okay. All right, so now here we are with example 4. Now let's look at example 4. First of all, just look at the 2 equations, because one of the things we're thinking about is golly, period. If we notice, tangent has a period of pi. Okay, so right now we're looking at the left side of the equation. Tangent has a period of pi, so it looks like maybe we'll be using plus pi k, but cosine has a period of 2 pi. But let's look at specifically for cosine 2. Let's just cosine 2x. Hey, our b is 2. And so our period is 2 pi over b. Oh, and this period is pi. So for this one, we can see that we're going to be giving answers plus pi k. Now, before we solve this equation, let's look at the 2 ways that we have graphed this one. Now, we know that you don't have both graphs on your paper, but this was using the intersection method, and this one is using the x-intercept method. So if we change this equation for the x-intercept method, we would have written this on our paper first. And this is the one that I thought we would probably do today. Tangent x plus 4 cosine 2x equals 0. Okay, so if we graphed it this way, this kind of makes it a little easier for us to find our zeros. All right, so, but you can see the intersections that correspond to those when we look at the 2 graphs. Yeah, when we look at the 2 graphs separately. All right, and also if you look at the left-hand graph here, you can see that this graph is going to repeat itself. Okay, so the pink graph is the cosine graph and the green graph is the tangent graph, and you can see it's just going to continue to happen that way. So our solutions are 3 solutions.
Negative 0.683 plus pi k. X equals 0.974 plus pi k, and x equals 1.280 plus pi k.
Okay, and they're going to keep on going. All right. Okay, our last problem we're going to do today, we have to be in degree measure. So pause the video, and to graph it in degree measure, you need to be sure that you're changing on the graphs, geometry, and graphing setting.
Yeah, the geometry and graphing setting. If you forget, if you're in the scratch pad, you see the gear up in the top, you can click on that, and that is going to change it for the scratch pad only, which would be useful.
Oh, okay.
So if you just click on that, it'll pull it down a menu, just press on settings, and then you can change it, graphs and geometry.
Right, and if you're watching the full video and then planning to do the problems after watching the video, remember that problems 1, 2, and the one you're getting ready to get here, 3, are in radian mode, and problem number 4, problem 4, will be in degree mode. So make sure you're in the right mode or else you're going to really screw up. All right? Notice we are going to graph 3 cosine squared theta minus 2 theta minus 3. Notice, however, even though the equation says theta, look that you have to use x's.
Because this is still a calculator. It doesn't understand theta.
Yeah, not in this mode anyway.
Yeah,
it understands it when we get to polar coordinates.
If it was graphed in polar, it would, but it's not. So.
Okay, so notice that we've already taken the liberty of graphing it. Notice how our x-axis has changed because we're in degrees. We're going up to 370 because that's a little bit past 360, and we know that 1 time around the circle is 360. And
look at the interval. That's a big deal.
Yeah, we want only the solutions between 0 and 360. So this means you're not going to be doing any plus 2 pi k things. We want specific solutions. Also, why did we choose negative 10? Because we always like to see the y-axis in our graph when possible. All right, so we go to graph this. Notice that what we've done is when you go, this is kind of an art in learning how to set your window, but notice that what we've done also is our little increments are happening every 90 degrees. Okay. Now, how do you do that when we're dealing with the radian graph? You can actually enter pi. So we did in the previous graphs. Go back one real quick. On this one, that right there, see that negative 1.5? That's pi over 2. So you can actually enter pi over 2. This 0.79 is pi over 4. So you can enter those in for your scale, and it'll read pi. It will understand what that means. You can either go and type the pi signal, or you can since the pi symbol, or you can actually type the letters pi, and it reads either one. All right, now let's go back to the degree problem. All right, so here we are. So it looks like we just have 2 solutions in that interval. Once you've kind of gotten it in the right degree, the right mode, you should be able to get everything you need.
But because, yes, I know it's x in the problem, like in the calculator, but we're going to use theta for our answer because that was the original variable.
Yes.
At 136.12 degrees. And since we're being asked for up to less than 360 degrees, we're not going to add anymore. It is period. It has a period it's going to keep going, but we only want the solution that's between 0 and 360.
I have a question. What if I didn't stipulate just a solution interval? What would we add plus 2 pi k?
No, because we're not in pi anymore. We're in 360 degrees, so 2 pi would actually be
equivalent
sorta to 360 degrees. So if I wasn't given this, then it would be 136.12 degrees plus 360 degrees times k.
Yeah, but always look to see if you have an interval. We kind of like, for the simplicity's sake of your answers, we kind of like to give you intervals, but there will be some times when we don't give you an interval. So.
And the other one right here is at 223.88. No, we don't have 3 decimal places.
Yeah, I know. I know. I didn't know. So
Ms. Dockstader forgot to find it to 3 decimal places.
Sorry, my bad.
You are expected to find that 3rd decimal place.
Yeah.
Come to class with the 3rd decimal place.
There you go. Okay.
And that will be part of your entrance ticket.
Yes. So for those people that actually watch this, please label this extra ET. Okay.
And don't you dare tell the people that aren't watching the video.
Because we know there's some that aren't, and these are the people that are slowing you down when you're paired up with them to partner because they haven't watched the video. They're expecting to just copy someone's note or have a tutor that doesn't watch them, that doesn't watch these videos help them, and they're the ones that are slowing you down, and they're the ones that make Ms. Meller and me very angry in class. So FYI, there you go.
All right, next ET problem. Solve the equation graphically.
Notice number 3 is a radian problem. Number 4 is a degree problem. And again, be sure that when you come back to class, you have your calculator reset to radian mode because we are going to do most of the problems in the class activities in radian mode.
I mean, this shows you degrees. It's also in theta, so that's a way to look and see if it's
Yeah, we're going to try to be consistent that way. If we put a theta, then we're going to want it in degrees. And if we have anything else, we're going to use radian.
X and T. All right, so here's what you need. 1 new thing, 1 good question, 2 old skills, and don't forget to bring your entrance ticket,
Plus.
Entrance ticket, ET+. Problems and complete notes when you come to class. Thanks. See you later.